built in with that solution solved. It has a mechanism to kind of have the two sides agree on what the states are going to be. It comes with a sharing mechanism as well. There's this thing called the packed broker, which I think go/packed will just go to. Maybe. Oh yeah, it's the old stuff. That's good. So this is a server that we've just run on Micros, like an instance of it. And this is the mechanism by which the two sides share their tests. So consumers, when they run their tests, and if they go green, they upload them to this broker. So here's an example of Ham's Atlassian ID uploads its tests. And you can see here, it's a JSON file, and this is a HTML representation of it. These are essentially all the tests. You know, things like, given there is one user, when I create a user with this request body, this is the response, and so on. There's just lots of different tests and assertions and that sort of stuff. So the broker allows both sides to just know about URLs, and we can just upload to these URLs, and there's a tagging mechanism as well. So for example, we have development versions of these tests and production versions of these tests, because they're not necessarily the same thing. So the production version of the client has a packed file that represents that, and that allows the producer of an API, in this case Atlassian ID, can pull down the expectations of our production client and validate that that works against their current development version. Well, they can also pull in our dev client to make sure that works, but whether that works or not is not as important, right? Because that potentially has work in progress stuff. Okay. Yeah. I think that pretty much sums up. Yeah, is there any questions? I'm kind of saying a lot of things. Yeah.
So you mentioned that you run tests against both mocks and the real system, right? So that that's your way how to keep mocks kind of represent what production is?
Yeah, so as we've evolved, we've come to think of Pact as essentially a mock server, a mock that is validated against the real thing later on. So that is one way to think of what these tests are. The way you write the test is not that much different to when you sort of normally mock out sort of HTTP requests and responses, except the difference here is that everything you do with that, or every interaction you make with that mock, is captured, shared by the pack broker with the real system, the provider, and validated. So yeah, you can think of this as contract testing, but another way to think of it is validation of your mocks.
So what about variables in those requests? So there might be things like we need authentication headers, or we might need to do some, back and forth to get the authentication that we then use for the subsequent requests and stuff like that. How does that handle that?
So for things like sometimes you have unique IDs, say in responses or requests, you can put in patterns like regexes and things like that. You say, I don't know what the exact value is, but I expect it to look something like this. So that's one capability. For things like authentication, sometimes we're using, for example, JWT for some of our interactions, and that involves an established private key that is kind of a pain to worry about in these tests. So what you can actually do is, when the provider runs the test, it can kind of jump in before the request really goes through to the server and say, I'm going to override the authentication header to be something that I know will work for my development server. So authentication, we special case when it's too much trouble to get working, because you find out pretty quick when your authentication's not working anyway.
Of course, if what you're trying to test is the authentication, then obviously you wouldn't special case it like Ben just said. So, for us, the authentication is kind of a thing that we have to do because security is important, and obviously we care about the authentication, but the vast majority of the tests that we're testing are testing functional errors that have nothing to do with authentication. For your example, it sounds like probably the authentication is the whole point, is that you're trying to test, so you wouldn't like a lot of what you're doing, most of these requests is, you know, checking that this thing is actually allowed to make this request to install this thing. So you probably wouldn't stub out the authentication in the same way as we do.
No, but later we would.
Yeah, sure.
If this is as good as it looks, then we want to use it for all sorts of things.
Yeah, for sure. Sorry, I just wanted to clarify for this specific use case.
One more thing I might add after seeing you put up a graph with lots of HTTP requests packed. The authors of Pact are very, kind of having played around with it, have formed the opinion that Pact is better for testing individual interactions rather than sort of chaining large sequences of interactions together. I think the kind of motivation for that is just things get a bit hard to like maintain all the different states and things like that. But they do kind of push you in the direction of testing individual interactions rather than, say, mocking out 3 different, say you mock out Jira and Bitbucket together, right, in order to test a bit of functionality. That would require you to coordinate states between those 2 external systems, and things can get a bit tricky at that point. So they kind of push you away from that, saying that you can do that, like nothing stops you, but you'll run into kind of scaling issues as you get more and more external dependencies. You need to coordinate states between all of them, things like that.
I was just going to ask, what sort of process do you follow when these tests break? Does that mean you revert things? Does that mean if the API's change, you just go and update both sides? What do you sort of do in those cases?
Yeah, so it depends on how you've got it configured in your build. So for us, we run these tests for every single build that we do, including branch builds. And so we follow the procedure that you're not allowed to commit to master directly. You have to create a feature branch. Any bug fix or new feature goes on that branch. And if you break it, then your branch won't go green because the pack test will fail. So there's not really a question of do we revert it on master, because it can't ever get to master because it wouldn't have gone green in the first place.
So I guess this is very client driven, so I imagine this works really well if you're controlling both the client and the service that you're hitting. How does it work if you've got multiple clients hitting one service, and can you get reports from the service side if any of the client expectations have broken?
So you kind of model it as an interaction between a client and a service. So if you've got multiple clients talking to the same service, then you'd have 3 instances of your pack tests, 1 for each client. So each client would be expected to write their own tests that verify that the particular API contract that they rely on is working, and they will submit a packed file for client 1 to server, client 2 to server, client 3 to server, and in the server's build plan, the server will run all of these packed verifications, and they'll see I broke client 1 or I broke all of the clients, so you'll actually get very rich feedback saying, I broke the ability for client 1 to make this particular thing work, or I broke all of the clients doing this function.
So if I'm trying to, so we want to have a new API perhaps, or we want to start using a new part of the API that already exists. So we will change the pack file on the consumer side until that gets green, but then we need to promote that like out of the branch build to somewhere so that the server, the provider, the producer can start saying, well, yes, we validate that this actually does work against our APIs. Or can I even as a consumer go, well, I should be able to write this package, I should be able to run it against them to make sure that my assumptions are correct. How does that sort of workflow work?
Yeah, so what the pack build is trying to stop you from doing is deploying a client that won't work with production. So while you're consuming new APIs that don't exist, and your packed file sort of shows the fact that you're doing that, it basically will stop you from deploying that. So I think your question is about how do you then introduce something like that. We have this distinction, like I said before, between development versions and production versions. So say when you update your client with these new assertions, the development sort of pact will not build against the, will not run successfully against the production version, but it may run successfully against some development version with that API partially built. And so that will kind of you can get the feedback, like as this thing's in development, like does it work with the development version of the provider that as they're building the API? And then if you look at it on the other side, on the provider's build, they're doing the same thing, right? They're running the expectations against dev and prod. So you would expect their changes to be backward compatible. So if they're introducing some new API, you wouldn't expect it to break the production clients. And they'll probably have a red build against the client that you're writing, depending on who makes a change first, right? So if say the provider wants to add the API first, it will do that, and I guess everything will be green because no assertions are going to be broken. But if it happens the other way around, if the client comes first, their development version will be broken against the validation on the provider side at first, until the APIs are built. And so typically the provider needs to launch the new API before the consumer can start consuming it. Does that answer your question?
I think so. I mean, is it normally driven from the consumer? Like the consumer says, hey, or you get together and you say, hey, we've got a new piece of functionality. Yeah. Who writes the pack file?
The consumer, all the pack files come from the consumer and are published to the broker. So if you're following the kind of consumer-driven mentality behind all of this, the consumer would go first, would write their client that integrates with the API and all the tests that go with that. And that, what interesting things happen there where the provider might implement the API and it still doesn't work. And then you kind of discover disagreements or misunderstandings between the two teams as part of that process. Because in conversation, things like you can agree on something, but then like, you know, the detail of what the requests and responses are actually going to be and what the interesting states are, there might be differences of opinion there.
Yep. Okay.
Sorry, just on there. Remotely. Hi. Just how practical or how applicable do you think PACT is to situations where you don't control, if you like, the server? So, for example, with SourceTree, we might want to test against kind of GitHub kind of APIs and stuff. And obviously, there's half of PACT potentially we couldn't use, but is it still? Do you think it still has a applicable to that sort of scenario?
I think you could use it. It's just you would wind up having to do the verification yourself. And things like changing states get a little more tricky. So perhaps there's other tools that you might look at instead of PACT for this kind of world, because you're more interested in validating against a third party and not necessarily having that. PACT is all about giving both sides the feedback, and in this case you're not really interested in one of the sides, right? So there's probably better tools for that specific problem.
Okay.
Yeah, so it's sort of like in your traditional kind of contract testing, you might have your SourceTree tests, which actually create a new GitHub account, verify that some API works, and then delete the account or something like that, right? And you might think you don't want to run that every time I run my build because A, it's slow, and B, maybe GitHub will ban my IP address or something. So you could perhaps look at using PACT for something like that. Now you're doing what Ben said, you create a mock of GitHub, you run your tests against the mock, and then maybe on a daily build, you actually run the mock against the real GitHub and get it to create a real account and make sure that those tests actually are representative of what GitHub looks like. So you could do something like that, but you then have to think, I'm putting a whole bunch of extra effort in to do this. Is it worth it? Versus maybe I'll just run my tests once a day instead of on every build. What benefit do I gain from this extra effort?
Okay. All right. Cheers.
So I think we all sort of came up with similar questions to you guys when we were first talking about PACT and implementing. But our actual experience of implementation has brought up different roadblocks to all those questions that we had at the start. So if it's all right, I'd like the guys to talk a bit about the experiences of that implementation and what we faced, the problems that we've had to overcome and some that we haven't overcome.
Yeah, I might just run through really quickly one of the integrations that we have, which is from the pricing experiment service to HAMS, and then I'll let Andrew have a think while I'm doing that about what problems he had while building it, because he was the one that built most of it. So you've got like 5 minutes to think now. You're welcome. Just a sec, guys. That's probably not readable, is it? Alright, can you guys all read that comfortably? Yeah? Alright, cool. So we've got these two systems which we kind of mentioned earlier, the pricing experiment service and HAMS. So HAMS is our billing system, and it needs to talk to the pricing experiment service to find out information about a new pricing experiment that we may be running. So this is a one-directional dependency. Pricing experiments doesn't talk back to HAMS, so that kind of makes it a little bit simpler to think about. In a lot of cases, you might have both directions, but you probably just treat them as two separate interactions where you've got service A talking to service B, and then service B talking to service A, and you implement them both separately. So to begin with, we've got, I need to make this font size bigger as well. I'll just open it in the console. Okay, so we've got this class here, which is kind of the accessor class for talking to the pricing experiment service. So this is code in HAMS. This is the actual code that HAMS uses in production to request experiment data and enroll accounts in experiments. It's not especially interesting. I'm just showing it to you so you can see it's just making HTTP calls, and this is the exact same code that we use in production and also the same code that runs in the tests. So this is nice because it gives us confidence that the tests that we're writing are testing that this actually makes real HTTP calls, and they're kind of acting as unit tests for this class as well in a sense, because if you were to unit test a class like this, one way to do it would be to start up a mock HTTP server and to verify that when you call the get pricing plan ID with an experiment key, that it makes this HTTP call and then marshals the response and marshals the request and unmarshals the response and everything like that probably. So that's kind of the same code that we use in both places. And then we have this packed test case. So we've got a bunch of constants at the top here. Here we've defined the provider and the consumer and the provider name. So these are the same names that you saw showing up in the pack broker, and these end up in the packed JSON file at the end of the day as well. We only have one state because it's a fairly simple interaction, but you can define multiple provider states. So a provider state is something like there is an experiment with this ID in the database, and if the provider is in that state, then you would expect that you can make a GET request for information about that particular entity, and you'll get results back. So here we only needed to have one state, which was nice. But in a more complicated system, you might want to say that this experiment exists and it has this product in it, or you might want another one that says there are two experiments and one of them is active and one of them is inactive, and things like that, and so you could define multiple states. So the way this works is we're using this packed library, which was provided by the real estate guys, and the tests kind of look like this. So you say, given your particular state, and then, so that's actually a meaningful string which the provider needs to implement. Every single state that you say that you're testing with, the provider needs to implement something for that state and fill the database with whatever is necessary. And then you have this upon receiving thing, which is kind of a description of what you're trying to do. So if your test fails on the provider side, this is their clue as to what they broke for you. So if you don't put something meaningful in there, then they're going to have no idea why your request is failing. This is just kind of a description of what you're trying to do. And then you define what your request is expected to look like. You define what your response is supposed to look like. You can put as little or as much detail in here as you want, but ideally you should only put what you actually need to verify in there. So if the provider sends back 100 fields in the JSON, but your client only needs 2 of them, then ideally you only put those 2 fields that you actually need into the response. And that way the provider is free to change the other 98 fields without breaking your client. And they'll actually know that they won't break your client because they'll know your client can't possibly depend on them. And you'll know that you're not breaking your client as well, because if your client starts to require another field, then it's going to fail this test because this test doesn't have that field present. So that works quite well. So you define your request and response state. You can define multiple ones if you want to, but as Ben said, it's kind of easier if you limit the number of things in each mock to the smallest number as possible. So we managed to get it down to 1 in every case, which was quite good. We only needed to mock 1 request with 1 response for each test case. And then you call your actual API, so your actual code. So this is calling that code I showed you earlier in HAMS, which is actually the real production HAMS code that tells the experiment service. And we're looking at the result that we got back, and then we're asserting that it is what we expect it to be. So what this is doing here is this is actually starting up the packed mock server with this stub request and this stub response. And then it calls my callback function that you can see there. And my callback function gets to run while the server is running. When my callback returns, the server is shut down. So if you actually put sleep in here, you can connect to the mock server yourself. I think it starts on port 8080 or something. You can configure the port, and you can actually connect to it and make those requests yourself, and you can see it's actually responding with what you expected it to. But don't do that, because if you do that, you're going to fail your test. Because the other thing that the mock server does is it records all of the requests that are made to it and the responses that it sends. It saves them to a JSON file. And then at the end of it, it checks that every single request that you stubbed out will actually be made. So if you set up a stub for a request to fetch a pricing plan ID, and then you never actually fetch it, then it's going to say you missed something. So maybe your code's broken. You shouldn't have set up that expectation. So it records all those expectations and responses, saves them to a JSON file, and that JSON file then goes to the pack broker. So I can run that and show you what it looks like. Sorry, free. No, I'm in the JSON file. Sorry, I don't have one I prepared earlier. Okay, so it drops this file in the target directory, and so this is the JSON output it's produced from that that packed mock server that we saw. So you can see it's got the provider name, the consumer name that we had at the top. It's got a list of interactions. So here we've only got 1 interaction. That's because I only ran 1 of the tests in the test suite. If you ran multiple, you get 1 interaction for every test that you run. And within that interaction, we've got your provider state, and your request and your response. And so you can see it's just put the bits in the request and the response that we've actually put in there. So it looks like we're actually, as part of our pack tests, we're actually assuming that the server has this exact authentication, which is because we haven't really done very good authentication in this server. It always has the same username and password in dev. So we could just always send the same username and password and it will always work in the dev environment. So that works fine. Yeah, and so that's the pack JSON. And so then when you run this on the other side, so this is all run in part of the HAMS build. This is the consumer. So on the other side, we take this file, we upload it to the pack broker, and then in the pricing experiment service, which is the service, the provider downloads this file and it starts itself up and it runs this request and it checks that this response is given. And so that's just one of the tests that actually runs like half a dozen or a dozen or so. But I'll show you what it looks like. Actually, any questions about that before I go on? Yeah.
One question. What happens if the entity body is not JSON?
Good question. I'm not sure.
So the pack specification doesn't exclude things that are not JSON, but today all the libraries and clients that are out there only support JSON. If you wanted to, say, use XML or some other type, you would have to extend the libraries to support that.
Yeah, we use JSON because we like JSON, but if you have existing APIs, you may have difficulties.
Atlassian has existing APIs that don't use JSON.
Yeah, I know. Fortunately, we weren't in that situation. But that's a very good point. Okay, so that was all on the. Any other questions? Yeah.
So when you run this on the provider side, who is managing state? So if you depend on a certain state on provider side, is it part of Pact?
Yeah, so the provider states have to kind of be agreed upon between the consumer and the provider. So if as a consumer you want to test some new functionality and you decide that the only way you can write that test is to have a new state, then you have to get the provider to agree to implement that state in their build plan. Otherwise it's not going to exist. So you can add a new one anytime you want, but it's not for free. Every new state that you add, the provider has to say, for this state I need to go and create these entities in the database or whatever. Alright, I'll move on to talking about how we implement it in the provider now. So we've got this file here, which runs inside the pricing experiment service. So it goes and firstly, actually, you know what? You explain this, Andrew. Sorry, I said you had 5 minutes, but you wrote this and I've forgotten how it works.
Cool, so this is the pricing experiment service. And
so this runs inside the pricing experiment service build, right?
yeah, oh, no, this is,
I'm looking at the wrong file.
yeah, no, this is 10.
This is the one that runs in, oh, no wonder I got confused. Alright, yes, they should. Is it this one? Yeah, that's the one. Alright. Alright, I think I know what I'm talking about again. I was looking at the wrong file. Sorry. Alright, so inside the pricing experiment service build, we are actually using Ruby, the Ruby version of Pact. So there's actually quite a few versions of Pact out there for different languages and different frameworks. There's quite good support for Java and very good support for Ruby. There's less good support for JavaScript. So if you're writing JavaScript clients, there's a pretty good library for that, and we kind of spiked that, and that worked pretty well. But if you're writing a JavaScript provider, that isn't quite so easy. So I know Ben looked into that a little bit and had a pretty good stab at implementing it using some hacks to use some of the Ruby stuff, but I don't think that got accepted, and I don't think you finished your ultimate plans.
It's a work in progress.
Yeah, still a work in progress. So we decided that we were just going to use the Ruby version of the Pact provider testing in our Node.js project, which turned out to not be too bad. The main troubles that we had with it was that we had no idea what we were doing with Ruby, and we kind of had to learn a bunch of Ruby along the way. I knew some very basic Ruby, but I learned a lot more. So one of the problems that we had was that the built-in libraries don't support opening a file if it has spaces in the names, which was really dodge. So we just monkey patched that to fix it, and I think Andrew's got a pull request on GitHub, which you're totally going to get back to and fix that properly in the actual version so no one else hits that. So then what we do is we define our service provider, and we're just configuring our application. So this is just how do we start our application. Firstly, we need to, I think, delete everything in our database. So this is just in dev, so we just start up the application, wipe the database, and down here we define the provider states. So as I said, we only had one provider state. So if you had more, you would just duplicate this section once for each state. So this is what I meant whenever you said you wanted to add a new state. As a consumer, you have to get the provider to add a new chunk of code like this. So for us, we only had one provider state to set up this provider state. So the state was experiment 1 exists with the pricing plan ID 42. We clear the database, we call this create test experiment function, which just calls our actual service API. So we have an API to create an experiment, so we just call that API from inside the packed tests, and we check that it worked correctly. And so if you wanted to set up other states, you would just do whatever you wanted there. So you could call your own APIs, or you could just inject things into your own database manually, or do whatever you want to set up those states.
Is the first thing you do for the state, you're calling ClearDB, so if you've got more than one state, you're going to throw away the all?
So that's kind of up to you and the consumer to decide on. So if you say that the provider state, this exists in the database, means that only that exists and nothing else exists, then yeah, you need to clear the DB. But if you wanted to, you could just say, in this provider state, we'll guarantee that this thing exists, but we don't want you to make any assumptions about anything else in the database. For us, we just decided it was easiest just to wipe the database completely clean each time, to avoid the chance of there being any flaky tests that fail because of bad assumptions. Then there's no harm in doing that, because every time we run this, we spin up a completely empty Docker database anyway, so there's not any old data. Yeah, so that's kind of all we had to do, really. We kind of just defined the states, and when I say that's kind of all we had to do, it took us ages to get it working, but that's kind of all of the code that you need. You kind of just define your states, and you tell it where to find the packed file that you want to run, and so it downloads the packed file from the pack broker, and it runs it against these states. And so the Ruby code that sort of manages all of that in the back end is part of the library. And so you're just telling the library here, this is how you start my service, this is how you set up these states, this is how you shut it down. And you tell the Ruby file, please run the tests for this packed file, so the JSON file I showed you earlier. You say, please run all of these verifications, and whenever it gets to a new provider state, it'll call this code to set up the state, and at the end of it, it shuts down the service, and you're kind of done. So while it took us a while to get there, it's kind of not much more complicated than that. So there are a few other little pieces in there. So you've got like your gem file, where you have to depend on packed, and we had to depend on this rack reverse proxy thing. So because the Ruby stuff is designed to be used with Ruby applications, it's actually designed to specifically be used with Ruby rack applications. So I don't really have a very clear idea of what Ruby rack is, but I get the sense that it's kind of like Ruby's version of servlets or something like that. I've not ever worked with it, but some very nice person out there wrote a rack implementation that just forwards to HTTP calls. And so we just say, like normally the way you're supposed to do this in a Ruby application is you say, hey, I don't need you to start or shut down my server or make HTTP calls or point you at a URL. You just point it at an instance of your rack application, and it doesn't actually make HTTP calls, it just kind of does it all internally using Ruby method calls. Obviously that's not going to work for us because we're using a Node.js app. So for us, we actually start up on Node.js app on a particular URL, and we kind of fake it to make it look like a rack app with this rack reverse proxy. So if you're using Java, you wouldn't have to worry about that.
They've introduced a way of, they've introduced a kind of lower level library that allows you to avoid all this rack stuff. You can just do the packed verification against a URL. So this is no longer necessary.
I think we tried using that and it was horrible. Yeah. This was the thing that used Rake.
Anyway.
Yeah. Well, this is what we came up with as like the least bad solution, and it ended up being not too bad. So I think just up here we're defining our service provider, and instead of defining our service provider as just importing our Ruby app, we define it as a rack reverse proxy to base URL, and we export base URL to be what our Node.js app is running under. And so that turned out to be fairly easy to do. Yeah, that's kind of it. There's this script in there, which is what we actually use to run it. So this is what we run from Bamboo. Bundle, which is just kind of pulling in all of the Ruby dependencies from the gem file. And so we just exec pack verify. So this is what I meant by the packed library is kind of doing most of the work for us. And we just say packed verify, please use this as your helper. And so that tells it how to get all the provider state information. And packed URI is where it should get the JSON file, the packed file from. So in our build plan, we kind of just pass in the packed URL, and it grabs all those provider states.
Do you know the state of flooding for Python?
The question is, do we know the state of it for Python? I haven't looked. I don't know. I don't imagine it would be great though. Java and Ruby seem to be really well supported outside of that. Is it? Okay, cool. Any other questions about that? All right, Andrew, do you want to chat a bit about your difficulties?
Yeah, so nothing really springs to mind apart from the fact that we were kind of quite new to kind of Ruby in general and Pact. So I think if I just talk about kind of like how we went about implementing it, and you guys can just jump in with questions. So first, I guess we wrote the tests on the consumer side, which is HAMS. As James was showing, you define your mock provider, and basically, if you make this request to this URL, you're going to get this response back. So that's not going to really do much apart from kind of simple unit testing. And then you can take that pack file and just on your local computer, run it with a pack verifier on the provider side. So this is kind of like your first time running the test, and that will show you the initial problems with the integration. So we found 3 different errors, and it was actually really good. So once we fix those up, then you can basically get uploading to the pack broker and putting it down on the provider side. So
What were the 3 problems we found?
they were real simple things. So one was to do with the authentication token, and one was the content type.
Wasn't it also like we had a string instead of an integer somewhere?
Yeah, one was a string instead of
Yeah.
like implementation details. Yeah, so
It's
then
kind of a nice thing to catch though. Like you're sending a string when you're expecting an integer. Most clients will work, but it's nice to make the assumption specific.
so then you kind of get to things where like before you upload the pack file on the consumer side, you want to validate that the pack file is correct. So what you've been mocking is actually what the provider is going to do. So that's when we were running it against the dev and the production pricing experiment service before we uploaded the pack file. And then on the provider side, we wanted to check that when we were making changes, it would work against the master and the dev version. So things like that were just simple changes to Bamboo, and it's quite easy. So on the provider side, the Ruby library pretty much does all the magic for you. You just give it the pack files and set up your states. I can't really say much more than that.
When you run it against production and dev, is that just running Bamboo branch builds against the different versions, or?
So we've actually got it
what's the
set up
setup?
as jobs.
Yeah.
So what it does is, are you talking consumer or provider side?
How you set the whole CI up for this? When you said you're testing both against dev and prod.
I can actually show you how that works if you like. So we've got in our pricing experiment service plan. So this is in the provider. I'll just show you the Bamboo plan. Maybe this wasn't a good idea. Maybe I'll show you the plan template. You guys can understand plan templates, right? This is much quicker. Alright, so this is on the provider side. So this is our normal plan. We've got a task that builds our just npm install grunt. So this is for the Node.js app. And somewhere in this grunt task here, we actually run the packed verification as well. So this isn't actually done specifically in Bamboo, because we didn't just want this to be a Bamboo thing. We wanted this to be a thing for local development as well. So if you're modifying the provider, the pricing experiment service, and you're running grunt watch, and you're getting like the instant test loop feedback stuff, you should get instant feedback if you break the pack test as well. So the way that looks in our code So we've got our grunt default and grunt watch somewhere down here, and they end up calling this pack test local thing, which shells out to that script I showed you earlier. So that just runs that bundle exec packed verify thing. That's ultimately what happens there. So on the provider side in Bamboo and in local dev, that's really all it's doing. It's just running that packed verify thing that we saw.
Yeah, so this is HAMS, the consumer. So when we pull down the pressing experiment service, what we do, the provider.
Yeah.
Okay.
Yeah, so that's the provider side. Do we? We run that in the provider,
Oh yes, but we run master and prod. So
but we run that from the consumer. Yeah. Alright, I'm just going to check and see which one we actually run. Okay, no, he's right. We run this one, master and prod, from the... Okay, well we run one of them from the provider and one of them from the consumer.
We don't know
What I wanted
So-
to know specifically was if Pact had any support for like the versioning.
The
at all.
versioning?
Yeah, so testing against master or prod, like within the Pact.
Yeah, so the way that works is via tagging on the pack broker.
You didn't read your homework.
So essentially, the consumer will upload a file, and that will automatically be available on a URL that's like that's /latest. And so the provider will just point to /latest, and that's the dev version. And then the consumer can make a call to say, this specific packed file, tag it with the tag production. And we can all agree that production is the tag we will use to point to the production version. And so the provider also points to a URL that's like /tag/production, right? And so it doesn't actually need to know when the consumer is changing things. It just, whenever it runs, it points to that URL and it's always pointing to the right thing.
Thanks.
Are you guys doing any end-to-end integration testing, or is it all back now?
We still do a lot of end-to-end integration testing, but for these services that we've done with Pact, we don't do any automated end-to-end integration testing. We rely exclusively on Pact. But I still think it's prudent to do an end-to-end manual integration test whenever you're making major changes to a customer user experience or something like that. Because, yeah, I think it's a good idea to do that sometimes.
We haven't really had it long enough to get enough customers to say yes, it's going to solve all of that.
It's also quite difficult to detect if you're missing tests and states. So, you know, only through experience and watching things break do you find out that you're missing a state that was interesting. So, yeah, some smoke tests are still needed to get the confidence to release.
So you mentioned there are still some unresolved problems. Can you tell us about that?
I was thinking
So far, the biggest unresolved sort of problem that we have is library support. So as you've seen here in the middle of our Node.js application, we're using the Ruby implementation. It hasn't been terrible, but it's just a bit unfortunate. You know, if you're using other languages like Python or things like that, there's like no library support. So the barrier to entry there is you need to actually build the library as well as write the tests. Another issue we've been having is features are being added to the packed specification, but they're not all implemented in every library. So for example, regular expression support is in, I think, the Ruby version, but the Java version doesn't support it yet, which is kind of they're just teething and like maturity issues with the testing framework. I think it will be resolved eventually, but there's just certain capabilities that are in some libraries that are not in others. It's not easy to find out that incompatibility exists until you write the test, use the feature, and try and run it on the other end, and suddenly it goes, oh, I don't know what this regular expression is. When you're integrating the same languages together and you're using the same libraries, like we have a lot of Java things, for example, that is a lot less painful.
So we are on time already. I don't know if you got any other questions. Something else to say, guys?
Yeah, I figured out what I was trying to say earlier. So this is the URL for the packed production file, and that's the URL for the packed latest file and the packed local. And we run that packed bundle exec packed verify thing with both of those in the local dev loop for the provider.